Hello friends, today we are studying choice of electrical drives and the status of DC and AC drives. The choice of electrical drives and the status of DC and AC drive. So first we will discuss the choice of electrical drive. So before we going to start this bit, first of all we can understand why this bit is very important in concern with university examination point of view. Because in a day-to-day life, while we are using any type of drive for a particular application, the choice means the selection of electrical drive is very important. And this choice or selection of electrical drive is basically conduct on the various parameters. Such parameters are called as the first parameter, which is called as a requirement related to the supply. Now, what do you mean by the requirement related to the supply? First of all, the choice of electrical drive is depending upon whether we are having AC supply or DC supply. Along with that, we want to consider what should be the magnitude of the voltage, what should be the voltage fluctuation, what will be the power factor, and what will be the harmonics level of that particular electrical supply. So that will be the first parameter while we are choice of electrical drive. Along with that, we can understand the second type of parameter of your electrical drive is called as the very important parameter. This is called as the nature of drive. So first we will discuss what do you mean by the nature of drive. Nature of drive means it is classification of drive. Before we going to select any type of drive for a particular application, second parameter is very important, that is called as the nature of drive. Basically the drive is classified as the three parts. First part is called as individual machine, second one be the group of machine, this is called as a group drive, and the third type of classification of electrical drive is called as multi-motor drive. So depending upon that we can understand the nature of drive for a particular application. Basically what do you mean by the individual machine? If the individual motor is used for a particular application of a machine, then it is called as individual machine. If we are using the group of machines for a particular application, for a use of a particular drive, this is called as group of machine. And multi-motor machine means that we are using the n number of drives to driving a particular one type of machine. So this is called as the multi-motor drive. So this will be the very important parameter while we are choose the electrical drive. So along with that, we want to understand the next parameter. This is basically very important parameter which is concerned with the choice of electrical drive, and that the parameter is called as the cost and maintenance requirement, because we are dealing with the different types of cost. So as we know that there are different types of cost of your electrical drives. Such cost are maybe capital cost, maybe maintenance cost, maybe your installation cost, and maybe running cost. So the capital cost and the maintenance cost should be considerable its value while we are selecting or the choice of electrical drive. So this will be the very important parameter of your syllabus. Then the next point of syllabus is called as the nature of load. So again, there are different types of loads are there. Depending upon our requirement, we are using the different types of load for different types of application. So the first requirement related to the load, that is called as a load requires very light or heavy starting torque. This is called as TST, because as we know that while we are selecting a motor for a particular application, we want to understand its torque and speed characteristics, and when we are considering the torque and speed characteristics, then the starting torque, running torque, and developed torque is very important as concerned with the electrical drive. So this will be the very important parameter while we are choice the electrical drive. The second one, which is called as whether the load torque increases with speed remain constant. So next, the very important parameter which is in concern with the load torque, because it is related to the starting torque. Second point is related to the load torque. Basically load torque is equal to function torque or friction torque plus windage torque. So then that in concern with the electrical drive, so that will be the remain cost. Okay, So this will be the very important parameter of your electrical drive. And the third type, that is whether the load has a heavy type of inertia, may require longer for a longer time. So such kind of requirement or the choice is required in concern with the when a DC series motor is required for a traction purpose, which will require very large inertia in concern with the traction, and as long as that the starting torque is concern, we are referring the DC series motor for a particular application for a traction purpose. So this will be the another choice of your electrical drive. Along with that, now we want to understand the next choice of electrical drive, and that next choice of electrical drive is in concern with the electrical characteristics of motor. So what do you mean by the electrical characteristics? So as we know that the motor is the device which will convert, that is the electrical energy, into a mechanical energy. So the mechanical power is basically given by the product of torque and speed. So that is a torque and speed characteristics is very important in concern with the motor concept. And in concern with the torque and speed characteristics, we want to understand the starting characteristics of your motor. Along with, we want to understand the running characteristics of motor and the various speed control and braking characteristics, because while we are considering the choice of electrical drive for a particular application, we want to understand its starting characteristics, we want to understand its running characteristics, we want to understand its speed control methods, we want to understand its different braking characteristics. So this will be the very important parameter while we are considering the basically the choice of electrical drive. So along with that, now we want to move towards the next choice of electrical drive, and this point is very important because this point is in concern with the size and rating and duty cycle of your motors. So what do you mean by the size of motors? Because the electrical drives are available in different sizes, so depending upon our requirement, we can choose the different size of electrical motor for a particular application. Then the second parameter is concerned with the rating. So depending upon the power rating, current rating, and the load requirement, we can choose the electrical drive. Then the next parameter is called as duty cycle. Duty cycle, basically duty cycle means in concern with the whether the motor is going to the operator for a short time or whether it is run continuously intermittently on a variable load cycle. So such kind of understanding is very important while we are choosing the electrical drive for a particular application. Then the next point for the choice of electrical drive is called as the mechanical consideration. What do you mean by the mechanical consideration? Means while we are selecting any type of drive for a particular application, we want to understand its mechanical consideration. So in mechanical consideration, we want to understand the various concepts. Such concepts are called as the type of enclosures, means which type of enclosures that we are using for the choosing of the electrical drive. Then which type of bearing, because depending upon bearing, it will bears the capacity of load that particular. So that will be the very important parameter while we are choose the electrical drive for a particular application. Along with that, we want to understand the transmission of drive. Transmission of drive means what? We are considering the concept of motor and load combination, because depending upon this motor and load combination, the transmission medium will be select. So the transmission of electrical drive is very important parameter. Along with that, we want to understand the noise level of that particular machine. So this will be the very important parameter while we are choose the electrical drive for a particular application. So along with that, now we want to understand the next choice of electrical drive, and that choice of electrical drive is called as space and weight restrictions, because the drives are basically used at different location and different spaces. So the space requirement in concern with the drive application and weight restriction, this basically depending upon where we are using this type of electrical drive, and for sake of that understanding, we want to use the different types of drives are in a aerospace and in a vehicle space. So the space and weight restriction has more weightage while we are choosing the electrical drive for a particular application. So along with that, we want to understand the Next type of the choice of electrical drive, and this choice of electrical drive is basically the requirement related to the steady state operation. So what do you mean by the steady state operation? Steady state operation means what? When the drive is running at a steady state condition. So in concern with the steady state operation, the first parameter is called as the speed torque characteristics. Speed torque characteristics, again, it has a various weightage in a torque speed understanding for electrical drive. So this will be the first parameter. Then the second requirement in concern with the steady state operation, this is called as speed regulation and its range. What do you mean by the speed regulation? Speed regulation is called as no load speed minus full load speed divided by the no load speed. So it will give you the value of the speed regulation. So while we are selecting electrical drive for a particular application, we want to understand the concept of the speed regulation and its range. So range is again in concern with the rating of your motor. So that will be the very important parameter. Then the next parameter is called as efficiency. So what do you mean by efficiency? Efficiency is called as the output of machine divided by the input of machine. So output of machine is basically considering the all type of losses in that machine, and the input of machine, that is the power required for your machine, that will be the very important parameter in concern with the choice of electrical drive. Then the next is duty cycle. Duty cycle is the operation cycle of that particular motor. Then the duty ratio, again it will be treated as the ratio of duties in concern with the choice of electrical drive. And then very important parameter is the quadrants of operation. So basically the drives are operated in four quadrant of operation. This four quadrant operations, first operation is called as forward motoring. This is the four quadrant operation. This will be the first quadrant, this will be the second quadrant, this will be the third quadrant, and this will be the fourth quadrant. So in first quadrant we are understanding the forward motoring. Second quadrant we are considering that is forward braking. In third quadrant we are considering reverse motoring, and in fourth quadrant we are considering the reverse braking. So this will be the very important parameter while we choose a electrical drive for a particular application. Then the next parameter for the choice of electrical drive, it is called as transient operation. So what do you mean by the transient operation? Transient operation means what? When the drive is considering in the different state. So we'll understand one example. What do you mean by the steady state operation and what do you mean by the transient state operation? Suppose we are considering, suppose one motor is running at a specific speed of 1500 rpm. So this is the steady state condition while the motor will be the running. Okay, suppose one of the parameter of the motor, such parameters may be your voltage is decrease or the current will decrease. Okay, then the speed of that particular motor will be the reduced up to the value of 1200 rpm. So that condition is called as the transient condition. Okay, so this condition, the speed value is reduced, that is the steady state value of speed of that particular drive is 15,000 rpm, but now it will be reduced to the 1200 rpm. So that condition, because this condition will happen due to the change in the different parameters of electrical drive, so that state of changing of the speed, whether the speed is changed, that is reduced, or due to the change in parameter, the speed of your motor should be increased. So this is called as the transient state. So in transient state we are considering both the concept of acceleration, deceleration. What do you mean by the acceleration? The speed get increased, so this is called as acceleration. And deceleration means what? When the speed get reduced, so this is called as a deceleration. That is a transient operation while we are choosing the electrical drive for a particular application. Then the next choice, that is called as starting of your electrical drive, and the next, that is braking. So as we know that in electrical braking there are different types of brakings are available. Such braking are called as dynamic braking, resistance braking or reverse braking, that will be the called as. Then the next parameter is called as the reverse performance. So what do you mean by the reverse performance? Reverse performance means what? The drive will be operated in a reverse direction. So these are the various choices of electrical drive. So guys, this will be the very important point as concerned with university examination, because most of the time in university examination such kind of question is basically asked for the 5 marks. So this is in concern with the choice of electrical drive. So let's will move towards the next bit of your syllabus. That bit of syllabus is called as the status of DC and AC drive. So again, this will be the very important question in concern with the university examination point of view, because most of the time in university examination such question is basically asked for the 5 marks. So what will be the weightage of that particular status of DC and AC drive? So guys, up till now we have studied the basic concept of DC drives and the basic concept of the AC drives. Now we want to compare these DC drives and AC drives while we choice for a particular application. So this bit is called as the status of DC and AC drive. So what do you mean by? We will understand what do you mean by the DC drive. So along with the name itself, it will indicates it will be a basically DC drive. So as we know that the name itself indicates it uses the DC supply. This will be the first point in concern with DC drive. So in AC drive we are using obviously AC supply. So depending upon our requirement, while we are using the supply which is called as AC supply, then it is called as the AC drive. So we have the concept of the drive. The drive is called as the system employed for motion, called it is called as a drive. When we are employing the electrical motors for the motion control, this is called as a DC drives or DC motors. So in concern with the DC motor and DC drives, we have the different classification of DC drive or DC motor. Such classification is called as shunt, series and compound motor. So this will be the different classifications of the DC drive. So along with that, the AC motor has a different classification. Such classification will be called as induction motor or the synchronous motor. So depending upon our requirement, we are using such kind of the AC drive. So this will be the another status in concern with DC and AC drive. The next point of the comparison between the DC drive and AC drive. So DC drive will require the circuit that is called as a control circuit or the operation circuit. It is quietly less complex, but in concern with the AC drive, the circuit is more complex in concern with the selection of the DC drive and the AC drive. Why the circuit is complex in concern with DC drive? Because in DC drive we are using the rectifier type of control circuit. So as we know that the classification or the construction of the rectifier is simple as compared with the converter that we are using in concern with the AC drive, that is called as the cycloconverter or the inverter. So the complexity of the AC drive is quite more. Okay. Then the next parameter of the choice of electrical drive, that is required related to the power. So as we know that the DC drive will carry the more power, because the construction of the DC motor is quite complex. So that's why the requirement of power for DC drive is very important. Along with that, we should know that we are using AC supply. So we want to convert that AC supply into DC supply by means of the rectifier. So the requirement of power in large in concern with the DC drive. But in concern with the AC drive, we are having the AC supply. So we don't want to convert that AC supply into another type of supply. So it will require the less power as compared with the DC drive. Then the next point is called as high starting torque. So as we know that the DC series motor which will possesses the starting torque, that's why the DC series motor we are using for the traction purpose. So DC drive or the DC motor will possesses the high starting torque, but in concern with the AC motor, the starting torque of such motor will be quite less as compared with the DC drive. So that will be the status of DC drives and AC drives. Then the next parameter is called as a lower dynamic response. So the dynamic response in the state of the transient state stability, or the in the state of the transient state response. So the dynamic response of the DC drive is always low, and the dynamic response of AC drive is always higher because of its characteristics. Because the speed torque characteristics of the DC drives is different, and the torque speed characteristics of the AC drive is obviously different. So this will be the choice of your electrical drive. So now again we want to move towards the next status of DC drive and AC drive. So for the understanding of that status, we want to understand the speed control methodology of the DC drive. So DC drive basically using the different speed control technique. Such speed control techniques are called as, basically in concern with the DC drive, we are using the armature voltage speed control technique, then field flux speed control technique. So these field control techniques are quietly simple, so that's why we can considering the simple speed control methods of the DC drive. But while we are discussing the AC drive, the speed control is quietly complex. Because why the speed control is quietly complex? Because the speed control methods of the AC drives are different. So basically there are n number of types of speed control method. So the first speed control method for the AC drive is called as the supply voltage method speed control. Then the second, that is a speed control method depending upon the fundamental formula, that is Ns is equal to 120f upon P. So by the changing of the frequency, we can control the speed. By the changing of the pole, we can control the speed of your AC drive. So the circuitry for the second speed control method, that is a change in frequency. Then next type of speed control method that we are using for the JC drive is called as the rotor resistance. Then next type of speed control method is called as the, basically, slip power recovery. So in slip power recovery scheme, we can cover the slip power. So the circuit for the speed control for supply voltage, change in frequency, rotor resistance control, slip power control. So the circuit of that particular speed control method is quietly complex as concerned with the DC drive. So this will be the very important point while we are getting the status of DC and AC drive. Then the next parameter for the choice of electrical drive is called as the speed limitation. So what do you mean by the speed limitation? The speed limitation of the DC drive may be up to the 3000 rpm, but the speed limitation of the AC drive may be 15,000 rpm. So the speed of your AC drive for a particular application, we can limit the speed. So the speed of the AC drive is longer than the speed of the DC drive. So that will be the another point while we are status of DC and AC drive. So after that, basically the next important parameter in concern with the concept of the harmonics. Basically the harmonics will be present in the AC supply. So in concern with the AC drive, the harmonic will be present, and basically in a DC supply we are using the supply that is called as DC. So DC supply doesn't contain any content of the harmonic. So the basically harmonic is absent in concern with the DC drive. Similarly, in concern with the AC drive, the value of the harmonic is always present. So basically we are using here, that is the AC supply. So in concern with the AC supply, the value of the harmonic is present. So this will be the next very important bit for the choice of electrical drive, or basically in concern with the status of DC drive and AC drive. Then the next point of comparison is that due to the commutatorless, the efficiency is more, because in concern with the DC drive, the construction of the DC drive, we are using the carbon brushes, we are using the commutator. The commutator is the circuit in the DC drive which will convert that the alternating or that basically the supply AC voltage is converted into a DC voltage. So due to the commutator, the efficiency of your DC drive is less. Okay, but in concern with the AC drive, there is no commutator present in that particular AC drive. So due to the absence of the commutator, the efficiency of your AC drive will be obviously more. So that's why we are preferring, instead of the DC drive for a particular application, we are preferred the AC drive for our applications. Okay, so the next status of the DC drive is in concern with the weight. So the weight of that particular DC drive is weight is large because the presence of carbon brushes, because of the presence of the commutator. The weight of that particular DC drive is heavy. But in concern with the AC drives, while we are comparing this the DC drive, the weight should be less, or the AC drive which has the lightweight concept. Okay. Then the next status of DC and AC drive is called as, in DC drives we are using the devices which is called a chopper, which is called as rectifier. So as we know that, what do you mean by the rectifier? Rectifier is a device which will convert alternating current supply into a DC supply. Okay, and in chopper we are converting, that is DC supply into DC supply. So as we know that the rectifiers are using different power electronic devices. So depending upon requirement we are using, that is AC supply, because our load is DC. So we want to convert that AC into DC, we are using rectifier circuit. And your load is DC and your supply is DC, then we are using obviously the chopper. So because these are the different power modulators are required for the DC drives as well as the AC drives. So after that we will getting the concept of the AC drive, that is the AC drive will using the different types of power modulators. Such power modulators are called as a cycloconverter and inverter. So in concern with the cycloconverter, we are basically having the change in frequency, means what, we are having the AC supply and our motor is the AC motor, then we are using obviously cycloconverter or regulator for that particular application. But if we are having the supply voltage of DC and our motor is AC, so that time we are using the power modulator is called as the inverter. So these are the different power modulators we are using for your AC drives. So this will be the very important parameter or the status of your DC and AC drive. Then obviously due to the its construction, the cost of the DC motor is always greater than the cost of the AC motor with the same rating. So the cost is more expensive in concern with your DC drive, and the cost is less expensive in concern with your AC drive. So that will be again the status of DC versus DC drive. So basically such kind of DC drive are used in hazardous environment. So there is possibility, that is the use of DC drive in a hazardous environment is maybe possible. But in concern with the AC drive, we are not preferring these types of AC drives in a various hazardous environment, because while we are selecting such a kind of DC drive, the weight of DC drive is quietly larger, the size of DC drive is quietly larger. So maybe it will be using in a hazardous environment. Okay, then the next point of comparison in concern with the cost, that is the cost related to the maintenance cost. So again the maintenance cost of the DC drive is quietly large, because in a DC drive we are using the carbon brushes, we are using the commutator. So it will require a frequent maintenance, so it will require large maintenance in concern with DC drive. But in concern with the AC drive, the maintenance cost is less, because the presence of the commutator is not the presence of the carbon brushes is not available in a AC drive. So the maintenance cost of the AC drive is very less as compared with the maintenance cost of the DC drive. So guys, this will be the explanation of the DC drive and AC drive. So thank you very much.